Further to discussion on unsupervised way of learning in data science. So, K-means is like in unsupervised there can be many ways when we try to label the data, and the most basic is clustering. And among the clustering, the most basic is K-means. So we will kind of proceed on the discussion of on K-means. So K-means, even though it is unsupervised and we don't know the levels of any experimental data, but still means K-means find the clusters, and clusters are directly associated to classes. So if I find two clusters, then I can think that data is it can be categorized in two classes. So K means we can say it's a kind of hard way of clustering. Means it's a multi-class, but it is not multi-level. Means even though it is unsupervised, but still we can say it is a multi-class or multi-level. Like we have a soft clustering, like expectation maximization. But in hard clustering, like K means, we cannot expect that one cluster can belong to two classes, but one cluster belongs to one class, but still one cluster must belong to one class. So what are the key points? So anyway, we are proceeding toward the disclosure, but still we'll kind of discuss that what are the key points in K-means algorithm, unsupervised clustering algorithm in data technology or data science. So there are three factors that are crucial that we see in the K-means. One, the first factor is that in K-means we start with the centroids. So how many centroids we expect? So how many clusters we expect? So that is prior. We should know in the prior that how many clusters we expect. We know. So that number of cluster is important because that much classes we are expecting. Another is that we select the random centroid. So each cluster, like sand dunes in desert, we see sand dunes, and we can consider those as clusters. So how many sand dunes it would make? So if there are two clusters, then how many clusters? So two clusters. So how many clusters that is required? And then means if you see the K-mean algorithm also in sklearn library, it takes number of clusters. And what would be the randomization? So the cluster means, so the initial seeding. So which all data points or document points it would select as the beginning point. So that is crucial. So which all points, which all if it is two clusters, then which all two random points it would select that at the beginning. So that is crucial. Number of clusters we choose, that is crucial. And then, so two things comes in K-means. One is reassignment. So when we reassign a sample data to a particular cluster based upon the distance. And another thing is recalculation of the centroids. So three things are important in K. How we randomize the initial seeding of the centroids. So where we select the initial centroids, how many centroids, and then we go with the two phases. One is reassignment of the sample data and the recalculation of centroids. So in the third phase, recalculation and reassignment. What would be the distance measurement we would do? So generally we say Euclidean distance, but Euclidean distance certainly it may not be perfect in many cases. So when we talk about the clustering can be geographical, means what we like if we see in the sky, then we see with some telescope, then we would see like Andromeda galaxy and anyway Milky Galaxy. There are many galaxies. So these are geographical galaxies, clusters that we see, or there can be logical clusters also. Means it would not look distributed geographically, but logically we can distribute. So three things are important. So when we see the randomization, means the beginning selection of the cluster centroids. So that is it. Like if I have two sand dunes, okay, then I know that there would be two clusters, and then I select a number of clusters as 2. But when we select the initial point, one point I selected outside somewhere, that happens to be one kind of outlier. Okay, so that will stick there only, and these two sand dunes and these two clusters, now they will belong to one centroid. Means completely missed. Means two class data, they are saying we belong to one class, and another class, what we expected, it is standing outside. So means initial seeding is important. So where the initial centroid would go, there can be many ways that we can think, like maximum distance we can think of, or we will try, and then if we see with some iteration that there are problems, then we'll try again, or we'll talk about with many tries we'll see the objective function or the minimum distance what we see. Okay, so short distances, so those things we calculate, and then we try to seed at the beginning how nice it would be. So that is the first thing. So initial random centroid seeding. So that is extremely crucial. Second thing is number of centroid, number of clusters, what we expect. So whatever input we give, so that is important. So I cannot say that if I think about the minimum distance, the minimum entropy, there is a term called entropy, the dirtiness in the data set. So when we finally come up with the clustering, so clustering is not we are shifting the data, we are kind of just fixing the centroids, and then we are selecting the clusters. So when we are kind of talking about the clusters, then dirtiness of the overall, it should be minimum. So the kind of, it should be pure when we end up. So the minimum distance, so all the cluster data, distance to its centroid, and if we sum up complete, then the impurity that should be minimum. So that comes like when we cannot say that, okay, so best thing is that can we have as many data points are there, then as many centroids we can say. So then everyone is very near to their centroid. It is as good as if my database belongs to two classes, then I am thinking about 1000 classes. It doesn't make any sense. Means expectation is that data will belong to two classes, so I will have two clusters. But just for sake of kind of decreasing the impurity, decreasing the entropy, we selected so many clusters, so that every data would be near to their cluster centroid. So that makes no sense. If two classes data belong to one cluster, doesn't make any sense. Or each data belongs to its own cluster, because entropy would be less, it doesn't make any sense. Means either way, it doesn't make any sense. So number of clusters are important. Means that gives us a sense of how many information is available. Number of clusters means how many informations are available. So that will go for toss. So number of clusters. So where the initial seeding of the cluster would be placed, number of clusters, that is important. Third thing is the distance. When we calculate the reassignment, that in each sand dune, each cluster, each point in the cluster, okay, their distance to their mean should be minimum in respect to their distance to the other mean. If we think in this way, then if we sum up all the distances, if I have two clusters, then in one cluster, the distance between each sample to its mean, total distance. Here total distance, if I sum up, that is also called objective of the k-means. So that should become minimum. So the entropy should become minimum. So distance when we calculate. So distance is abstract. So it's we are kind of in procedure to make the disclosure. So we're talking about a visitor design pattern that would best suit here. When we write the algorithm, then we kind of think about the steps, but later we'll decide upon the actual algorithm that will come into the picture. So visitor design pattern, that would come in a kind of behavioral design pattern. So that we are including in the disclosure. So which distance we do? Euclidean distance, or there are many distances like cosine distance. Like think about the two colors, RGB, so red, green and blue. One color is red, green, blue is 0. And one color is red, green, blue. So blue is there, red, green is blue. 1, 0, 0, one color is there. And one color is 0, 0, 1. Okay, so what would be the distance between them? And one color is 1, 0, 0. And another color is 0, 0, 0. What would be distance between them? Okay, so if we think about the Euclidean distance, then when we see the component of the distance, then it just sums up all the components. So if I see red and blue, then I believe their distance would be as good as black and 101. So if there is a color 101 and 000, it is same as 100 and 001. Means this is we cannot just subtract the component and then square it up and then take the square root. So that is Euclidean distance, because it is expected that it should be component wise contribution, not here and there. So we talk about the cosine distance in these kind of distances where component wise it matters. Okay, so like okay, so Euclidean distance we talked about. It can come under kind of dimension cursability also, because we think about only squaring and taking the square root. So cosine similarity or distance, that should work well in the coloring, where because we take the angle between the color. So if one is red, one is blue, or one is red on the x-axis and blue on the z-axis, then distance 90 degree means it is maximum distance. This is what is the expectation. If it is 0 and red, 0 or blue, then it will be like that only. So means the distances should be measured in the angle, not in the Euclidean distance. So how we measure the distance. So three things as we said. So that is crucial for the K-means. One is the initial seeding of the random centroid position, number of centroids, and then the distance measurement. So how we think about distance means whatever the cluster we are making, how logical it is, and logically what kind of distance that will put. So like for coloring, the angle distance. So in the angle in the sense, we consider color as sphere, and when angle shifts, the color shifts. So that way it would be a cosine distance that we would show. So that we take. Sometimes we take a single dimension also, and then we go for Euclidean distance. Like font size, if we are taking out the bigger font and a smaller font, then font size one dimension is also okay. Okay, so probably other distance may also be good if it is not like Manhattan distance, like that is called a cap distance also. So doesn't matter. So what distance we take, that is very crucial for making the data belongs to a particular, because if data belongs to a wrong cluster, it is also means impurity will be higher, and kind of we will have F1 measure, and then we have recall and precision. Those things it would change slightly. But two classes belongs to one, full two classes belongs to one class, or two classes belongs to 1000 classes. So those things is not tolerable. So three factors that any will see in the discussion.